Hello, this is Mrs. Mendy, and today I'm going to talk to you about chemical bonds. Remember when we talked about valence electrons, that atoms want totally full or totally empty shells. So if you're an atom that lives on the left side of the periodic table, like barium or potassium, their shells are closer to empty. They want to lose electrons. So barium has 2 valence electrons, so it's closer to empty. So it wants to lose those 2. Potassium is even closer. It only has 1 valence electron, and so it's much easier for it to lose that electron to get an empty shell than to gain 7 more. Okay. However, if you're on the right side of the periodic table, like fluorine or oxygen, they want to gain electrons because they're very close to having full valence electron shells. So fluorine needs just 1 more electron and then its shell is full. Oxygen has 2 that it needs and then it will have a full shell, but that's still pretty close. It's much closer than having an empty shell. So they go to gaining electrons. Remember also that losing electrons makes you positive because electrons are negative, and gaining electrons makes you negative because remember, regular atoms have no charge. They are balanced in charge between protons and electrons. So if you lose 2 electrons, like this barium, if it lost its 2 electrons it was looking to get rid of, then it's going to have a net charge of positive 2. It's going to be positive, it lost 2 negatives. So if the potassium loses its 1 electron that it wanted to lose to have a completely empty shell, then it will be positive 1. That will be its charge, okay, because it lost a negative. If you're fluorine, and if the fluorine got an electron from someplace, then it has an extra negative charge. So now it is negative 1 charge for the ion of fluorine. If you are oxygen and you gain those 2 electrons from somewhere in the universe, then you've got 2 extra negative charges. So now it has a charge of negative 2. So an ionic bond is what happens when the ions stick together because of their electrostatic charge. So they're either positive or negative, and those positives and negatives attract each other. So like this sodium ion newly lost its electron is now positive. It's now a sodium ion instead of a sodium atom. And it says, suddenly I feel so attracted to this negative chlorine ion because the chlorine wanted to gain 1 more electron and it did. And now it's saying opposites attract. So this positive and this negative will stick together and they can make great big extended molecules like this with all the positives and negatives sticking together. So that's an ionic bond when ions stick together. But there are other ways to have bonds. And the other one we're going to talk about is because sometimes atoms can get full shells by sharing electrons instead of giving or taking electrons. So here we have 2 chlorine atoms up here. And each of these chlorine atoms really, really wants 1 more electron because then it would have a full shell. But if there's nothing around that they can take electrons from, they can share electrons. So with the 7, 1, 2, 3, 4, 5, 6, 7 from this chlorine atom, and the 7 from this chlorine atom, if they share 2 between them, so that means that this chlorine atom has access to 8 electrons. Not all the time because they're sharing these ones, but this one does too. So that's close enough. So they feel good now. They each have 8 electrons, sort of, but they have to share these. So we call this a covalent bond. Covalent because they're sharing, they're cooperating and sharing their valence electrons. So covalent bonds are from sharing valence electrons. Okay, so here's an oxygen atom. It wants 2 more electrons to have a full shell because it has 6 right now. And if it happens upon some hydrogen atoms, They have one, and if they share their valence electrons, then everybody can be happy because these hydrogens have a full shell. Remember, hydrogens have that little bitty shell. It's that inner shell that can only hold two. And then the oxygen has 8 where it's sharing, and this other hydrogen has 2 also. So everybody's happy from sharing. A covalent bond is those 2 shared electrons. That's what makes up the bond. It's not a separate thing that it gets because of the 2 electrons. The electrons are the bond. Okay? Sometimes atoms share 2 pairs of electrons because we call that a double bond, and it's because that a single bond just doesn't satisfy their needs. Okay? So remember how oxygen atoms have 6 valence electrons, and there's 1, 2, 3, 4, 5, 6, and they want 2 more. So that if they just shared a single bond, that wouldn't be enough for them. But if they share 2 each, then they get this double bond. Similarly, you can have a triple bond. If the atoms involved want to share more electrons to fill up their outer shell. So like this nitrogen here has 1, 2, 3. It has space for 3 electrons. And it won't get that any other way unless it shares 3 and it gains 3. So now each of these nitrogens has access to 8 electrons here, and this other one has access to these 8 electrons. So that's a triple bond. Now, instead of showing all these dots, scientists got tired of drawing all these circles. For real, they got tired of drawing all the electrons. And so they wanted to make this simpler. So they decided to just show a single bond as just a line. So one line counts as these 2 electrons. And then they just didn't even show any of the other valence electrons. Because if you just want to show the bond, that's all you're showing. Okay? And similarly, if you want a double bond, instead of all these things here, you just show 2 lines. And if you want a triple bond, then it's 3 lines. But just remember that each one of those lines represents a pair of electrons, 2 electrons shared between the 2 atoms. Okay, see you next time.